Greetings everybody. So today we are going to discuss about the dry cell. So dry cell here basically it is a type of non-rechargeable cell. Dry cell is a type of non-rechargeable cell, and it is, in other words, a primary cell because it's not being recharged. And here it is one of the most common cell which we use in daily life for in toys as well as in remote as well as electronic watches. All of these contain this. Now, coming to the point that what is its composition first and foremost, dry cell is an actual composed of three major components as we have previously learned. There are three major components among which number one includes the cathode, which is the graphite rod. Now that cathode of graphite rod basically is surrounded by a thick paste of black carbon charcoal and manganese oxide paste is there, right? After that, when it comes to anode, right? So for anode, at anode we are having zinc as the anode because it is having higher oxidation potential. Less reduction, if the reduction potential is less, oxidation potential is higher, due to which it is utilized as an anode, right? After that, when it comes to the electrolytic solution used over here, electrolytic solution used in this case would be ammonium chloride plus zinc chloride. Ammonium chloride, zinc chloride. A solution of ammonium chloride, zinc chloride is utilized in the dry cell, and that is basically a molten. It's not in weight solution. It's not in the form of a what do we call it, as a solution with concentration of water in it. It's not an aqueous solution. It's a molten solution such that it is in a fused state of ammonium chloride and zinc chloride. And this is the reason we call it as dry cell. Dry cell means some it is having its electrolytic solution in the form of dry state or molten state or fused state. There's no water present in it. While when it comes to fuel cell, which we studied previously, was a weight cell because it contained the water inside it. So at that moment, it was weight cell, which was known as fuel cell, because there was aqueous solution. Here, it is a dry cell. Now coming to the point here, this is electrolytic solution, ammonium chloride, zinc chloride, and apart from that, there is another anatomy of this cell, such that uh, at the cell is in such a manner. At the center, we are having the cathode, graphite cathode, and surrounding that, we are having a paste. Surrounding that, we are having a paste of uh, surrounding that, we are having a paste of manganese oxide, right, and carbon charcoal. And after that, in middle, this complete region, this entire region is basically having the electrolytic solution, which is infused state of zinc chloride, ammonium chloride, right? And after that, we are having a partition, thin partition, porous partition between the zinc anode and electrolytic solution. Now that partition can be of porous paper. Moreover, out of that, we are having an insulating medium. Asphalt seal is there, metallic jacket is there, and one end is negative terminal, other end is positive terminal, right? And here, uh, the positive terminal is basically having a metallic brass over it. Moreover, apart from that, we are having a labeling outside. At the outermost part, we are having labeling of PVC, polyvinyl chloride, for marketing purpose and such, and also in order to insulate it, right? It is a bit of having in metallic state, such that polyvinyl chloride contains some metallic alloys as well. So in that case, it is a metallic PVC. Now, uh, when it comes to the amount of energy it produces 1.5 volt, right? And how does it actually work is that as a galvanic cell works, it basically works in such a manner that here, at anode, let's discuss the reaction one by one. At anode, the reaction occurs in such a manner that at anode we are having zinc. Zinc basically now has a characteristic to perform oxidation, which means it is oxidized. It is oxidized, as a result of which it loses its electron. As a result of losing its electron, it becomes zinc ions and loses its two electrons, right? This is the condition at anode. Now the zinc ion which are formed at the anode, zinc ion formed at the anode, now react with ammonium chloride present within the solution. Ammonium chloride present within the solution. As a result of this, the product which is obtained in this case would be zinc chloride plus ammonium ion, right? Now when it comes to the ammonium ion will further react. First let us balance this equation. Ammonium, zinc, right? So here there would be a 2, here there would be a 2. So this is the equation which is balanced. Now after that, what we are going to do is to now have ammonium, because ammonium is an ionic form, it is unstable. So in order to convert it into you know the form of a stabilized form, we need to take these two ammonium. Now two ammonium structure is in such a manner that here we are having, let's suppose this is one ammonium, uh, this is ammonium, this is hydrogen, this is hydrogen, this is hydrogen, and here it is having two lone pair, and one this lone pair is connected with hydrogen, right? And on the other hand side, if we talk about other structure, similarly we can copy this structure, right? So here's the other structure in this manner. So this is a structure which we have got of two ammonium. When these two ammonium react, what actually happens is that the two hydrogen which are formed here, they break the bond of the ammonium and leave that ammonium, and they tend to come closer with each other and tend to form a single molecule of hydrogen. While on the other hand side, the compound which is left behind is basically the ammonia instead of ammonium, which contains three hydrogen, one nitrogen. So at that moment, this would be the reaction occurring, as a result of which two ammonium would be now converted into the ammonia ions, to two ammonia plus hydrogen, right? So this would be the reaction occurring. Now instead of writing ammonium, we can simply mention it over here, that here there will be formation of ammonia, two ammonia plus hydrogen gas. After that, when we are going to combine both of these equations when combined together will give us the answer, which is in such a manner that here you know zinc will be cancelled with zinc cancelled with zinc, two electrons left behind zinc over here. So here when we are going to write it, we can write it in such a manner. Here there is zinc plus 2 ammonium chloride, zinc plus 2 ammonium chloride is equals to zinc chloride plus 2 ammonia plus zinc chloride plus 2 ammonia plus hydrogen gas plus 2 electrons. So this is a reaction occurring at the anode. Now this is the entire reaction occurring at the anode, and that would be an oxidation reaction because there is loss of electron on the anode side, on the zinc I and this is a reaction. When it comes to the cathode, at cathode the reaction would be in such a manner that here at cathode the reaction is in such a manner that here when these electrons are lost, electrons of anode are now transferred to the cathode. As a result of which, when these electrons are transferred to the cathode, an electrical energy is generated due to the flow of electrons. Electric current is generated due to the flow of electrons. And at that moment, when it is you know sent to the cathode, that moment at the cathode, we are having manganese oxide, which further reacts with the electrons. It further reacts with the electrons. Two electrons are given, right? Two electrons are given. And manganese oxide will be reacting. So at that moment, when manganese oxide basically now it is having its oxidation number as +4, -2 of oxygen, so +4 of manganese oxide. But when it will gain the electrons, when it will gain the two electrons, it will have its oxidation number decrease. Its oxidation number will be decreased. Let's see how. Here manganese oxide will react with the two electrons as well as with the hydrogen gas. Hydrogen gas which was formed at the cathode will also react, anode will also react at the cathode. Hydrogen gas as well as ammonia plus zinc chloride will react over here. Let's see how. And here what reaction which will actually occur over here will be in such a manner that here first and foremost manganese oxide will react with the two electrons. Better to write it in this manner. First there would be a reaction between these things. So here manganese oxide will now be converted into manganese trioxide. Manganese trioxide in its reduced form, which is manganese trioxide. Now as you can see in the manganese trioxide, the oxidation number of manganese instead of +4 is reduced to +3, right? Here the oxidation number was +4, here it is +3, which means that here oxidation number of manganese is decreased, and this indicates that here the manganese is reduced. Manganese is reduced. Now this is the first reaction. Now balancing the equation on both sides, here it will occur in such a manner that here there are three oxygen, two manganese oxide. So we are going to take two manganese oxide, right? So here when we are going to add two manganese oxide, so two manganese, same thing. Manganese will be balanced, and oxygen, there are two oxygen on left hand side, three oxygen on the right hand side, which means sorry, four oxygen on the left hand side and three oxygen on the right hand side, due to which one oxygen is also lacking. So that single oxygen which is given from the two manganese oxide will be reacting with hydrogen in order to form H2O, right? And this is the actual reaction occurring. After that, when it comes to the other part, we are having ammonia plus zinc chloride. Ammonia plus zinc chloride, this is a reaction occurring between both of them. Now what actually will happen here is that ammonia will react with zinc chloride at the cathode, and now the equation will be converted in such a manner that it will form a solid zinc structure, which is known as dichloride diamine zinc. Let us see how it occurs. Two ammonia were there actually in the previous equation, so here the equation will be in such a manner there will be zinc dichloride, sorry, zinc diamine dichloride present. This would be the reaction occurring, right? Zinc dichloride diamine, and that would be a solid form. It is a solid form, right? And the reaction will tend to occur until or unless there is no uh, you know until or unless the zinc is not completely decomposed into the dichloride diamine zinc. When the zinc is completely decomposed into dichloride diamine zinc, then we can say that the dry cell is completely finished, which means the it has no more power to supply electrical energy. Right? And when we have noticed that whenever we are using a dry cell, so on the label it's written that we should not place it near high temperature. Reason behind it is that whenever we are utilizing a dry cell, so in dry cell there is production of several gases such as ammonia gas, ammonia gas, gases produced, hydrogen gases produced, and these are gases which are having high rate of diffusion. They gain high amount of energy, such that if we are putting them at high temperature, then these gases will tend to absorb the high amount of energy and will tend to increase their rate of diffusion, increase their kinetic energy, as a result of which ultimately they will tend to explode the cell if given a high amount of kinetic energy, because their collision rate will increase, and a high amount of collision rate will cause the cell to ultimately burst and cause explosion at that moment. That is why we do not keep cells near high temperature. Moreover, there's another reason that sometimes we see that low quality cells have low quality cells become inflamed, low quality cells become swollen. This is the reason behind it, is that these low quality cells have low quality of insulating material, which causes which is unable to resist the gases present within it, such as hydrogen gas and the other gases such as the ammonia, due to which these hydrogen gas and ammonia not being resisted by the insulating material causes the cell to become swollen after a few period of time. So these are the two reasons why we actually consider it. After that, when it comes to dichloride diamine zinc, it is a solid in which the matter is decomposed completely. Now, the thing which we are going to do is to add up both these equations. Now, first equation is the one which is obtained at the anode, and second equation is the one at cathode. But before that, we need to summarize the cathode equations. So here, a cathode equation can be summarized in such a manner that here we are having two manganese oxide plus two electrons plus hydrogen gas plus zinc chloride is equals to manganese trioxide plus H2O plus zinc ammonia zinc dichloride diamine dichloride diamine. So this would be the actual equation over here. Now what we are going to do is to add up both equations. Now let us take the anode reaction. At anode we are having this equation. So this is the equation at anode, right? So as the equation at anode is this, we are going to utilize it. And on the other hand side, the second equation on cathode is this, we are going to utilize that as well. Now taking out the ultimate cell reaction which would be occurring here is that two electrons are cancelled out. Hydrogen gas and hydrogen gas should be cancelled out. Hydrogen gas cancelled out. Zinc chloride and zinc chloride, these are to be cancelled out. Zinc chloride cancelled out, and then well, I think we are missing one thing in the equation. That here we are having zinc, we are having two ammonia as well, right? So forget, write that. Here we are having two ammonia, two ammonia, right? So ammonia will also be cancelled out. Rest the equation which would be obtained, the complete cell reaction, which would be obtained would be 2 manganese oxide, 2 manganese oxide plus zinc in the free state plus 2 ammonium chloride, ammonium chloride, 2 manganese oxide plus 2 ammonium chloride plus zinc is equal to manganese trioxide plus H2O plus zinc, ammonia, zinc, ammonia, zinc dichloride diamine. This is the equation, final equation. This is the actual cell reaction occurring, and the cell will tend to work until there is complete decomposition of zinc into dichloride diamine zinc, which is a solid form. So this is all about today's video. Hopefully we meet again in the video.